Hi everybody. In the following video you will see a little summary of the Unit 1, Teaching and Learning Science in Primary Education. In this unit we will revise the concept of scientific literacy, how to teach science and the Spanish curricula, although this part will be done in the classroom. This unit will start with the scientific literacy, science, culture and society. In the classroom, we will start talking about what does it mean being science literate. The idea is to know the concept of science literate and the relevance of being scientific literate. As we will see in the classroom, there are different levels of scientific literacy. But we need to understand that being scientific literacy is something that could be a goal in the basic educations. As a teacher, we need to ensure that all our students acquire the minimum levels of scientific literacy. We will see this in a moment. Scientific literacy must form part from our all syllabus. As a teacher, we need to make sure that the basic concept of science are taught to our students, and also our students need to be able to understand and to develop scientific knowledge. So, as teachers, we need to be responsible of foster the scientific education. There are different levels of scientific literacy, but what we need to make sure is like all people reach this basic knowledge of science. Why we are so concerned about that? Because being scientific literacy will help citizens to make proper decisions, participate in civil and cultural affairs, and for sure making contribution in the economic productivity. Thus, there are three basic levels of scientific literacy, as we will see in the classroom. There is a basic or practical scientific literacy. Is the basic knowledge that allow us to make personal decisions. Also, there is another level, civic scientific literacy. This scientific literacy allow us to participate in the global decisions, to make decisions as society. So when we make decisions in which the scientific concepts are involved, we need to make sure like we understand and we make our decisions based on our criteria and as we wish. And finally, there is another level of scientific literacy, that is cultural literacy, cultural scientific literacy. And this literacy means like enjoying science, enjoying and discuss scientific topics, knowing important or relevant scientists, knowing or enjoying reading scientific documents, history of science, etc. So depending on the goal of our course, we will try to reach one or other level, but at least everybody should have this basic and civic scientific literacy. Also, another important thing we will learn during this unit is how to teach science. As a teacher, if we want to answer this question, how to teach science, we need to understand how science is learned. So science is learning. Learning science implies the acquisitions of scientific knowledge and the development of understanding. So imagine like we had these three situations in which there are three different objects inside a beaker with water. As we see in the images, some of these objects are floating and others are sinking, are in the bottom of the beaker. So if we want to understand what is going on, one side of that are floating and other no, we need to understand what is happening. So in order to acquire this learning, we need to understand the science behind this situation. And based on that, we will need to develop the understanding. So understanding science requires that an individual integrate the complex structure of many types of knowledge. In this case, in order to know why one object sinks or floats, so we need to know some ideas about science, the relationship between these ideas, the reasons for these relationships, ways to use the idea to explain and predict the other natural phenomena, and ways to apply them to many other events. In this case, so we need to understand the relation between fluids and solids, the relation between forces, and the existence of the buoyant force. Once we know all these concepts, the relationship between them, we will understand why some objects are floating and others not. So understanding science, therefore, encompasses the ability to use this knowledge and entails the ability to distinguish between what is science and what is not scientific idea. So once we have integrated all these concepts, maybe we can answer different questions. But why science is such a difficult subject? There are different reasons why people think, our future students may think that science is a difficult subject. Maybe because of conceptual concepts, or maybe because we are using in science high formal requirements, or because maybe students have initial ideas or misconceptions that make it difficult to learn science. So as a teacher, we need to understand how the science is learned in order to provide a better or a proper way of instruction. So there are different models, but in the classroom we will focus in two. The first one, transmission-reception model, is the more classic way to teach, and then we will also talk about constructivism model. The new scientific knowledge is built over the previous learned knowledge. I'm sure you're already aware about the transmission-reception model, in which the teacher is the person, the one having the knowledge, and is delivered to the students. Students learn this knowledge through instructions, and basically the knowledge is based on memorizing. As we know, this is not a very proper way to teach science because it relies on memorizing, but this is still in use. For instance, we introduce some concepts, making definitions, classifications, examples. We establish relation between the new and old concepts, and students learn those concepts, and maybe we make some application through problems and activities to apply this concept. But basically it's based on memorization. Although we know that this is not very effective way to teach, it's still broadly used because it's easy to deliver. And also, when thinking about transmission-reception model, teaching could be seen as an easy task. I just need to know the knowledge. Teaching and learning are just a transmission of the knowledge, and in all cases, the failure of learning is just a pupil problem. So we know this system, this method, is not the most appropriate. So we are going to be focused in the classroom in the constructivism. Constructivist epistemology assumes that learners construct their own knowledge base in the interaction with the environment. In here, according to Ausubel, learners are the builder and creators of the meaning and knowledge. So the teacher needs to guide the learners in the learning process. And we need to build scaffolds to ensure a active instruction and a productive learning. So in this case, learning involves inventing ideas rather than mechanically accumulating facts. So inside the constructivism model, we will talk in class the 5E models of instruction. In this model, there are 5 stages. The first one is engage, in which teacher connecting with previous and present learning experience. Once this engage phase is done, we need to explore. So we need to design learning activities to contribute building concept, processes, and skills. Also, we need to explain the concept that the students have been explored in the previous steps. And once these 3 stages are reached, we need to elaborate, put in practice these new concepts. At the end, as a teacher, we need to evaluate, assess the students' understandings and abilities. So we will work in the classroom with this model, and we will see some hands-on activity to put in practice these 5 E's instruction model. So in the constructivism, so we need to start knowing what learners already know. So we need to use productive questions. This is an important task in science, using productive questions. So we need to debate about the known ideas, and then try to incorporate, adapt the old ideas with the new ideas, so the students will develop the learning. So as we said, we will finish this unit talking about productive questions. So that's so important to learning science that we will practice in the classroom. There are different 6 types of productive questions: attention focusing questions that help students to fix their attention on significant details, measuring and counting questions, comparison questions, action questions, problem posing questions, and reasoning questions. So all these questions could be used in designing the instructions using the 5E method.